Chapter 8 is on sequences, and you're probably wondering what a sequence is. Well, it's actually quite simple. A sequence is just a list of numbers. So I could generate a list of numbers in many ways. How about the number of kids in my complex? Like in my house, there's 2 kids. Next door neighbor has 1 kid. There's another family with 2 kids. Then the house beside them, there's no kids. And there's one house that has 3 kids. So here's a list of numbers. We're not interested in this sort of list. How come? Because we're interested in this sort of list. This is, you're probably saying to yourself, arithmetic sequences. No, this is actually pronounced arithmetic sequences. Weird, eh? Arithmetic sequences. What's an arithmetic sequence? It's an ordered list of terms in which the difference between consecutive terms is constant. It doesn't change. The difference between terms doesn't change. It sounds confusing, but it's really not that hard. What's the difference between 2 and 1? The difference is -1. It went down 1. What's the difference between 1 and 2? 1. It went up 1. What's the difference between 2 and 0? -2. It went down 2. What's the difference between 0 and 3? 3. It went up 3. You see how these are all different? This means it's not an arithmetic sequence. An arithmetic sequence is something like, I don't know, -2, 1, 4, 7, 10. That's an arithmetic sequence. How come? Because the difference between -2 and 1 is 3, and from 1 to 4 is 3, and 4 to 7 is 3, and 7 to 10 is 3. Okay, that's basically what we're interested in this chapter. A couple other things. One, it can be infinite or it can be finite. So what I've drawn here is a finite sequence, because it just stops. But it doesn't have to stop. It could go on forever. How would I show it goes on forever? I would put comma, dot, dot, dot. Just shows it keeps going and going and going and going. It can also, so that's infinite in the positive direction. It can also be infinite in the negative direction. I could put dot, dot, dot down here to start the whole thing off. That means that the next term would be -5 and -8, -11, -14, and it goes forever. So it can be infinite on one direction or both directions, or neither direction, in which case it's finite. Also, it can be increasing or it can be decreasing. This is an increasing sequence. But something like this, 10, 5, 0, -5, that's a decreasing sequence. Finite or infinite? It's finite. There's no dot dot dots anywhere. It doesn't continue on forever. Let's put one more, -10. I don't know why. Okay, so we need a formula to deal with these arithmetic sequences. We're going to learn a few. Here's the first one we're going to learn today. T of n equals a plus n minus 1 times d. What do all these things mean? Well, a is the first term. Pretty simple. D is the common difference, right? In this case it was 3, 3, 3, 3. That's the common difference. N is the number of terms. Those are all pretty simple to understand. This is the one that gives people troubles. T sub n. It's the nth term, also called the general term. So let's use our example here, these red numbers here, and let's go through all these. A is just the first term. First term is 10, no problem. D is the common difference. So what's the common difference here? How much is it going up by every time? Well, it's not going up, it's going down. It goes from 10 to 5, which is a difference of 5, and 5 to 0, which is a difference of 5. So a lot of people think the difference is 5, but it's not. Because if the difference was 5 and you started with 10, what would the next number be? 15. So this is actually -5 and -5. Your difference can be negative. It'll be negative, obviously, if it's a decreasing sequence. If it's an increasing sequence, D will be positive. N is the number of terms. So let's count them up. 1, 2, 3, 4, 5. N is 5, because that's how many terms there are. So now we're left with T of n. We actually can't answer what T of n is. We need to be more specific. We need to say whether it's T1 or T2 or T3, because what that means, for example, if I put T3, that means what's the third term? Oh, that's not hard to figure out. 1, 2, 3. The third term is 0. By the way, what's T1? T1 is 10. But do you see that T1 is exactly the same as A? Yes, A and T1 are the same thing. It's just a different name for it. Some books actually don't use A. They use T1 instead. I kind of like that, actually, using T1 instead. But your workbook uses A, so we'll use it. What if I had T6? Wouldn't make any sense. This is a finite sequence, and it stops after 5. So that doesn't make sense. Okay, so consider the following numbers. We're going to answer some questions now. We got these numbers here. There's -4 and 2 and 8 and 14. And do these numbers represent an arithmetic sequence? How do you know? Well, we said what makes an arithmetic sequence arithmetic sequence is that there's a common difference. There's a constant difference between them. So if you want to know what the difference is between two consecutive numbers, like these two right here, the first two, you can take them and subtract them. You could do 2, the second one, take away the first one, which is -4, and you get 6. Or you could take the third one, which is 8, and subtract the second one, which is 2, and you get 6. Or you could take the fourth one, which is 14, and subtract the third one, which is 8, and you get 6. Do you see they're all the same? So yes, this is an arithmetic sequence. How do you know? Because there's a constant difference. Great. Next one, what's the 30th term of this sequence? We don't know the 30th term. We only know the first four terms. But there is a 30th sequence. There is a 30th term because look, ... it goes on forever. So the first thing I advise you to do with these questions is write this down and write down what you know. Do you know A? Do you know the first term? Yeah, we know the first term. It's -4. Do you know D, what the difference is? Yeah, we just figured out here. The difference every time is 6. Do you know N, the number of terms? Well, at first you might say, well, it's infinite. But you got to kind of look at like we're only considering the subset of this. We're only interested in up to the 30th term. So let's ignore the 31st, 32nd, 33rd, 34th, etc. term. Let's just worry about the first 30. In other words, the number of terms we're interested in is 30. Tn. Well, we can be more specific than that. We've just named n 30. So where you see n here, you can put 30. So what we're interested in is T30, which is the 30th term. That's what that means. We're wondering what the 30th term is. And no, we don't know the 30th term. We only know the first four terms. So how are we going to figure out the 30th term? We're going to use this formula right here. We're going to say Tn, or in this case T30, equals A plus n minus 1 times D. A is -4 plus n is 30, take away 1, times D, which is 6. We'll do the brackets first. So we get 29 times 6. So it's -4 plus 174. And if we add -4 and 174, we get 170. So the 30th term is 170. Next one term in the sequence is 4,796. Which term is it? So they're saying if you kept going up by 6 and 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 going up by 6, eventually you're going to hit that number, 4,796. Which term is it? So, do you know the first term? Yeah, it's exactly the same as it was before. It didn't change. It's still -4. Do you know the difference? Yeah, it's the same as well. It didn't change. It's still 6. Now, which one of these two do you know? Do you know how many terms it is? No, that's what they're asking for which term it is. But you know that one of the terms is 4,796. Oftentimes, this t of n here, you can kind of think of this. It's not always true, but it's often the last term. And that's kind of like what we're interested in here. We're interested in the sequence of numbers that go up to 4,796. That's the last term in the sequence we're interested in. So what number is that? This is the thing we're trying to figure out right here. Right? That's what we don't know. So we can use the same formula. T of n equals A plus n minus 1d. Right? A plus n minus 1 times d. Tn we know, it's 4,796. A we know, it's -4. N we don't know. D we know, it's 6. So there's a bunch of different ways you could solve this. I think I'd add 4. Why not? We'll move that over to the other side. So if you do that, you will have 4,800 on this side. And why don't we do the mountains on this side? So we'll have 6n take away 6. Now I'm going to add 6 to both sides. So I get 4,806 equals 6n, and divide by 6, and if you do that, you'll get 801. N equals 801. 4,796 is the 801st term. You would have to go out 801 numbers before you got to 4,796. Next, the comet Dennin-Fujikawa, love that name, appears every 9 years and was last seen in 2005. Will the comet appear in 3085? Okay, well let's start with our list. A, D, N, T sub n. So, do you know the first number in this sequence? Yeah, you do. I mean, 2005 isn't the first time that this comet appeared, but for our intents and purposes, it's the first time we're worried about. We know it showed up in 2005, so we're going to take that as our starting point. So 2005 is our A. Do we know the difference? Yes, it's 9. It appears every 9 years. So the next time it would appear is 2014. Hey, I'm making this video in 2014. So if you're in my class this year, you must be terribly excited when you saw this, and you must be Googling when is Dennin Fujikawa going to appear. Do that now. Next time it appears, 2023. Maybe I'm still teaching and you're watching this in 2023. Then it's in 2032. Maybe I'm still teaching and you watched it then. Oh God. No, that's okay. I'm happy to be teaching then, but I don't think I want to be teaching then. I think I'd be like 79 or something like that. Don't really want to be doing that. Okay, dot. It keeps going and going and going, hopefully. So, will the comet appear in 3085? Is 3085 the number of terms, or is that just a potential term? That's potentially one of these numbers right here. We're wondering, if I keep going and going and going and going, will 3085 appear? Will that be one of the numbers? So let's do this. Let's put 3085 here and then solve. This just looks like exactly the same sort of question as before. But it does have one wrinkle. This is a potential. Like, we don't know. Is this actually a term or not? Maybe it doesn't appear in that year. So how are we going to know? Well, let's solve it and then we'll think about it here. So, I guess I should write the formula. T of n equals a plus n minus 1 d. T of n is 3085, a is 2005, plus n we don't know, d is 9. I'm going to subtract 2005 from both sides. That leaves me with 1080. Let's do the mountains over here. So 9n minus 9, add 9 to both sides. So that's 1089. Equals 9n, divide by 9, divide by 9, and if you do that, you will get 121. So, will it appear? Yes. How do you know? The reason you know that it will appear is because this number right here is a whole number. If it didn't appear in that year, it wouldn't work. It wouldn't be a whole number. It would be a decimal. Now, I want you to think about n. What's n? N is the number of terms. Can you have a decimal for the number of terms? No. If I ask you, for example, how many kids are in the class, you're going to have a whole number. You can't have a decimal. And no jokes about half a person and stuff like that. Okay? N cannot be a decimal. It has to be a whole number. There's something else n can't be. What kind of number can n not be? Negative. N can't be negative. That doesn't make any sense for n to be negative. N must be a positive number. Because I couldn't ask you how many kids are in the class and you say there's negative 3 kids in the class. That makes no sense. And it's the same when you're counting numbers in a sequence. You can't have a negative number of numbers, and you can't have a decimal number of numbers. N must be positive, N cannot be a decimal. It's very important that you realize that. So when you're wondering if a number is or is not a term, is 3085 a term or not? Figure out N. If you get a whole number, it is. If you get a decimal, it's not. Alright, two terms in an arithmetic sequence are T3 equals 4 and T8 equals 34. What's the first term? So what I find the best way to explain this at first is to draw some numbers. So we have up to 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. And we know that the third term, 1, 2, 3, is 4. And the eighth term, 1, 2, 3, 4, 5, 6, 7, 8, is 34. And we want to know, what's this one? What's the first term? Okay, the first thing we should figure out is what's the difference between these terms. So the way you would do that is you take this term, and to get to this term, what would you do? You would add a difference, right? The common difference. How about to go from there to there? Add the common difference. From there to there, add the common difference. From there to there, add the common difference. And from here to here, add the common difference. So can you make an equation up from this? If you start with 4, you would have to add a difference, a difference, a difference, a difference, a difference. In other words, you'd have to add 5 differences, and that would give you 34. Now you can solve this and figure out what the difference is. We'd subtract 4 from both sides. You'd get 5d equals 30. You'd divide by 5 both sides. You'd get d equals 6. The difference is 6. Now, some of you might be saying, yeah, but that's really great if the numbers are close to each other, like the third term and the eighth term, but what if it was t3 equals 4 and t80 equals 34? How would we do that? Well, let's look at this. How did we end up with this 5 here? I mean, obviously the 4, you just took that first term there. And obviously the 34, you just took that term there. But how could you get this 5 here? Look at this, 3 and 8. You just subtract them. So for example, if it was this, t3 equals 4 and t8 equals 34, what you would do is you'd say 4, the starting one, plus how many d's would we have to do? 80 take away 3 is 77 d's equals 34. Okay, so you can do it that way. Or if the numbers are close to each other, which they often are, I'll tell you the truth, they often are really close to each other, you can just set up a drawing like this. Okay, the difference is 6. So we can definitely go this way now. If the difference is 6, what's this number? 10. This is good to do this actually to check your work. What's this number? 16. Add another 6, 22. Add another 6, 28. Here's where you can check your work. Add another 6, 34. Yeah, it worked. Okay, this is the number I want though. How can I do that? Well, there's two ways you could do it. The most sensible way, I think, is just to go the other way. If it was plus 6, plus 6, plus 6, how can you go this way? Minus 6. So this would be minus 2. Minus 6. This would be minus 8. There's your answer. Okay, there is another way you could have gotten this number. And, you might need to use this. If it wasn't t3, but it was t30, you wouldn't want to be subtracting 30 times to get the first term. So here's the other way you could do it. You could use the formula again. Tn equals a plus n minus 1d. And maybe I'll set up our a, d, n, tn. And here's what you do. Remember, we don't know these first two terms. Pretend we don't know those, okay? Don't know them. So what you could do is you could say, do we know the first term? No, that's what we're trying to figure out. Do we know the difference? Yes, you just figured that out. It's 6. Now, n and tn, what are we going to do there? What you're going to do is you're either going to treat it like the sequence stops at the third term or the sequence stops at the 8th term. Doesn't matter which one. What the heck? I'll do the 8th term. Let's say this is the end of the sequence right here. So how many terms are there? 8 terms. And what is, since n is 8, what's t8? What's the 8th term? 8th term is 34. Now we can solve this to get a. Tn is 34. A we don't know. N is 8. D is 6. So 34 equals a plus 8 minus 1 is 7 times 6 is 42. Subtract 42 from both sides. You get a equals negative 8. You probably can't read it, but this says negative 8. I'm sure you wrote it down before. So that's the other way you can solve it. Okay, I know if it's a very small term like 3, you're just going to subtract. But if that was t30, you might need to do it this way. Okay, last one. Find x so that 3x plus 2, 2x minus 3, and 2 minus 4x are consecutive terms of an arithmetic sequence. So what they're saying is there's 3 terms. The first term is 3x plus 2. The second term is 2x minus 3, and the third term is 2 minus 4x. And we have to figure out, what does x have to be? So it actually is an arithmetic sequence. So you have the same difference, the same difference. How are we going to do that? Well, remember how we get the difference between two terms? Let's look back here for a second. How did we get the difference between these terms? We took the second one and subtracted the first one, and we got 6. We took the third one and subtracted the second one, and we got 6. We can do the same thing here. We can take the second term, which is 2x minus 3, and subtract the first term, which is 3x plus 2. We could also do that here. We could take the third term, 2 minus 4x, and subtract the second term, 2x minus 3. That will give us a difference here and a difference there. What do you know about the differences in an arithmetic sequence? In an arithmetic sequence, the differences are constant. They have to be the same. So in other words, this difference and this difference should be equal. You solve this, you got your answer. So let's do it. 2x minus 3, take away 3x plus 2. Remember, this take away refers to everything here. If you want, you could rewrite this as 2x minus 3 plus, change everything in here, negative 3x minus 2. You don't have to do it that way, but you can. I'll do the same thing here. Keep the first one the same, change your negative to a plus, and then change everything in here, negative 2x plus 3. You don't have to do that. Okay, on this side, 2x plus negative 3x is negative x, and negative 3 plus negative 2 is negative 5. On this side, 2 plus positive 3 is 5, and negative 4x plus negative 2x is negative 6x. Let's get all our x's to one side, and I like to move the smaller one, the negative 6x. That way I'll have a positive number of x's when I'm finished. So negative 1x, right? That's a 1. Negative 1x plus 6x is 5x minus 5 equals 5. Add 5 to both sides. 5x equals 10. Divide both sides by 5. And if you divide both sides by 5, you get x equals 2. We're finished. We got it. Maybe you did that and you're not sure if it's the right answer, though. You can check it. Plug 2 into all these spots, here, here, and here. 3 times 2 is 6, plus 2 is 8. 2 times 2 is 4, take away 3 is 1. 4 times 2 is 8, and 2 take away 8 is negative 6. Now, what's the difference between 8 and 1? Negative 7. What's the difference between 1 and negative 6? Negative 7. It worked. It has a common difference of negative 7. Alright, there you go. That's a lot of information coming at you really fast. Hope you got the gist of it, and good luck.